Yeah, very good evening, dear students. I think you are able to hear me, right? And I will be the instructor for the very important subject for civil engineering, that is structural analysis. So let me share the screen and I start the session. Yeah, fine. So I hope the screen is visible to you. Yeah. So we'll start the subject called structural analysis. So structural analysis is a very basic course for civil engineering. So if you look at the syllabus for structural analysis, I divide into several chapters. Okay, we'll see the syllabus. And before going into that syllabus, the weightage for the subject for the examination, gate examination especially, is if you look at the gate exam, the weightage for the subject is around 7 marks. So I can say 7 marks is the weightage for the structural analysis for the gate examination. And if you write engineering service examination, ESE, and it is around 90 marks, including both objective and conventional together. It is. So in conventional, there is a more weightage is there for this subject. Okay, so you have to pay more attention towards the conventional part also, in addition to objective. And whatever we are going to deal is all about the objective oriented and also part of conventional also I'll be teaching, right? So in the structural analysis, people generally call it as simply SCA. So the structural analysis is a kind of subject where you can find a lot of numericals. They don't ask theory from this subject, and most of the things are numerical oriented. So you need to have some practice. Without practice, I think you will be doing a lot of mistakes in the examination. So my sincere advice is, so please, once you listen to the class, you try to practice the questions on your own. And we'll be doing many numerical questions in the class itself, like previous gate questions and other ESC examination questions. Okay, different models will solve in the class itself, right? Now, I think, am I audible to you, students? Voice and is it clear to everyone?
Yes, sir.
Okay, fine. Good. So if you look at the syllabus for the structural analysis, the syllabus is of, so I'll write one by one. So first one is the introduction to the structural analysis. So that anyhow I'll be explaining in the first chapter itself. And first chapter will be looking for static indeterminacy. So what is mean by static indeterminacy? So how to find static indeterminacy of a particular structure? So we will look at very clearly about indeterminacy of a structure. So what is the meaning of indeterminacy of a structure? Can you please tell me? What is the meaning of indeterminacy? Can you please just think and tell me what is the meaning of indeterminacy? Indeterminacy means something which we do not know. Determinate means, what is the meaning of determinate? Something we are able to determine, okay, with the help of available equations, especially equilibrium equations. Then we call that particular structure as a determinate structure, basically. So what is the meaning of indeterminate structure? The structure which cannot be analyzed by using the available equilibrium equations. So there we need to have some additional conditions called compatibility conditions, whatever it is. And we're going to make use of in order to find out the unknown quantities in the structure. That's what we call indeterminacy. So what is the meaning of static indeterminacy? We'll see that in the first chapter. In the second chapter, we'll be going for kinematic indeterminacy. So what is the meaning of kinematic indeterminacy? So when I say kinematic indeterminacy, what is the meaning of that kinematic indeterminacy? Kinematic means which is dealing with the displacements. So people also call this as the DOF. DOF means degree of freedom. You could also call it as degree of freedom. And it will be dealing with the possible displacement components of a structure. So, okay. So what I do is just I'm writing the syllabus, just you focus on to this, what I'm going to cover. But once I take individual topic, you will be really enjoy each and every class. So it's very interesting. Okay, please pay attention toward the topics. And the third one is all about analysis of trusses, basically, or we can say analysis of pin jointed structures. So analysis of trusses. So what are the trusses? Can you please tell me? What is the meaning of trusses? Trusses are nothing but pin jointed members. In trusses, every element is connected by pin joint. Okay, pin jointed structure also we can say. Sorry. Okay. So we can also call trusses as the pin jointed structures also. We could also call them as pin jointed structures. Fine. So how to analyze them? What is the meaning of analysis first? Can you please tell me what is the meaning of analysis? Anyone? Do you have any idea about analysis? So please be interactive in the class so that because it's a evening class, so you need to have more interaction basically. So what is the meaning of analysis? Analysis means finding out the unknown quantities. So if you are able to find all the unknown quantities in a structure, then we can say that the analysis is completed. Suppose, for example, if you are given a simply supported beam, let's say simply supported beam, and you are asked to analyze this simply supported beam. So what is the meaning of analysis of simply supported beam? That means you have to find out the reactions, reactive forces. If you are able to find the reactions, and if you are able to find out the maximum bending moment and maximum shear force, then we can say that our analysis is completed. Are you getting the point? Analysis means finding out the unknown quantities due to the applied actions. So what is the applied action here? Load is the applied action. So then reactions are going to set up, reactions are going to develop. So if you are able to find out these unknown quantities that are going to develop in the structure because of the external load action, then we can say that the analysis is completed. Okay, fine. So any structure is given, how do you analyze? We'll see that here, right? Before that, for that, you require to have some idea about the basic concepts of structures. That's why we'll see what is the structure, what is the meaning of indeterminacy, and it is divided into two parts, static and kinematic indeterminacy. And we'll see we have a very specific topic called as analysis of trusses. We call them as analysis of pin jointed structures. It is a very, very important topic for the examination. Whatever the examination you write it. It's a very, very important topic, analysis of trusses. Every year they're asking questions from this particular topic. So the fourth topic is all about the energy principles and also strain energy. So we can say energy principles. So what is the energy principles? What is the advantage of energy principles? We have several energy principles that are used to compute the displacements of a structure. So which is also very, very important topic. So how to determine the displacements that are developed in a structure due to external load actions. So this is also a very important topic to be focused, and many questions are appeared from this particular topic. So give more importance to this topic and this topic. And these are very, very basic concepts, and they're also asking questions out of this. And the fifth topic is all about basic methods of structural analysis. So what are the basic methods of structural analysis? So we'll see that here, basic methods of SA means structural analysis. And we have force method of analysis. And we have even displacement method of analysis. So there are several methods that are available here. Force methods and displacements method. We use any one of them, depends upon the type of structure we analyze. The most preferable method for analysis of structures is displacement method. So in displacement method, we have moment distribution method, we have Cornish method, likewise, okay, slope deflection method, okay. So in the case of force method, we have theorem of three moments. Okay. And we have several methods, but that is not that much important. Force methods are not important for the exam. Most of the questions will be asked from the displacement method of analysis because these are very simple to, easy to compute any unknown quantities by using displacement method. But the force methods are very tedious. Tedious means very lengthy. That's why they don't ask for the competitive examinations. So we have to focus more toward the displacement method. That's why I'll take separately one chapter called moment distribution method. So very, very important for the examination. Moment distribution method. Most of the previous questions, if you look at GATE, Eeci, most of the questions are based on the moment distribution method. It's very, very important topic among all. It's a very, very important topic. So this moment distribution method used to analyze the statically indeterminate structures, basically. Maybe continuous beams, frames, etc. that can be analyzed easily by using moment distribution method. And we have 7 chapter that is what we call influence line diagrams, ILDs, influence line diagrams. Simply we call it as ILDs actually. So influence line diagrams are simply we call it as ILD. So what is ILD? Can you please tell me, anyone? What is the meaning of influence line diagram or ILD? For example, you want to design a bridge structure. It may be railway bridge or road bridge. So how to design a road bridge or railway bridge? So usually the traffic will be there, right? So if you take a road bridge, so number of vehicles are crossing the bridge, right? Per unit time, let's say. Then you should be in a position to estimate what is the maximum possible loads that are coming onto the bridge and what are the maximum reactions like support reactions and bending moment, shear force. We're going to find out. How do you find all these things when there is a load moving from one end to other end? So for that, we need to have some methodology. So for example, imagine that a unit load, let's say unit load is passing from one end to the other end of a bridge. Okay. Then what would happen? What are the different quantities that are going to develop because of the unit load moving from one end to other end? What are the different quantities of forces? Like it can be reactions, shear force, bending moment. How they are going to vary? So we are going to show those things in graphically. The graphical representation of variation of parameters, we call them as the influence line diagrams. So if you know one load effect, and if you want to find what is the 1000 newtons load effect, just to multiply with 1000. That's what the very basic thing is. If one load is, unit load is causing some effect, what is the 1000 unit load causes into multiplied with 1000? That's it. That's why unit load concept we're going to use influence line diagrams in order to compute the unknown quantities whenever there is a movable load, especially for the design of bridges. It can be road bridge or railway bridge, even train also. When train is moving over a railway bridge, then also we should be in a position to compute the maximum quantities of reactions, shear force and bending moment. I'll explain very clearly. So when I enter into that particular topic, okay. So just at the beginning class, that's why I'm explaining about what the topics we're having. So it is also having very good weightage. So from this topic also, sometimes they're asking questions out of this. Sometimes they may not be asked. So we can say it's moderately important for the examination, but recent times they're focusing more on the influence line diagram. Recent examinations to look at, they're asking more about the influence line diagrams. So and we have even we have matrix analysis of structures, matrix method of structural analysis. So we have matrix method of analysis. And we have even analysis of arches, basically. Arches, analysis of arches. And last topic is plastic analysis. Plastic analysis of structures. So these are the 10 topics that are there for the GATE examination, GATE, Eeci, and other state level examinations also. This is the whole syllabus prescribed actually. So the same GATE syllabus is very standard syllabus. If you prepared for the GATE examination, the advantage is that you can appear for any kind of examination in India. Okay, so because the standard of the questions, whatever they are going to ask is very good. So basically they cover all the concepts. If you look at previous GATE questions, we'll be having complete idea about the entire subject. Okay, basically. So that's why what I am trying to do in my lectures is that, so I'm going to give full concepts of the subject, since because you are the final year students or third year students. So I assume that you do not know anything about structural analysis, and I'll start from the scratch basically, right? So everything I'm going to explain, so in detail. Okay, so I hope is it clear, whatever the voice or whatever it is it clear to everyone?
Yes, sir.
Fine. Okay, fine. So then, so we'll continue with the what is the meaning of structure basically. What is the meaning of structure? Can you please tell me what is mean by a structure? Can anybody tell? So I think you got some idea about the whole syllabus. This is the syllabus I'm going to cover. And look at your any GATE syllabus 2023, you can see. Okay, so this is what a syllabus. Even coming years also the same syllabus will be there. Okay. Now let us see what is the meaning of structure basically. So can you please tell me what is mean by a structure? Can anybody tell what is the meaning of a structure? What is the meaning of structure is? So when I say structure, so structure means a system basically, an elastic body or a system, we can say. It is an elastic body. It is an elastic body or system which offers resistance, to the deformations, caused by external loads, or forces. External loads or forces. So what is the meaning of this? So structure means, for example, you look at your own building, where you are staying now. Okay, you are staying at your home or hostel, whatever it is, and you're staying in a structure basically. Look at upside, you can find beams, you can find slab. Okay, yes or no? And you can find vertical elements, columns and all. So imagine a beam, let's say for example. Now imagine a beam, look at top and observe, are you able to find any deformation of the beam? Can you see deformation of beam in your home? No. So then if the deformation is visible, then we don't call it as a structure. Are you getting the point what I'm trying to say? So structure, if you want to call any system as a structure, that means that particular system should resist the deformations. Okay, deformations, if it is resisted, then it is what we call as the structure. So please try to make a note of that, which offers resistance to deformations. Okay, any kind of system, it can be elastic body or system, whatever it is, which offers resistance to deformations caused by external loads, then that is what we call basically as the structure. For example, I give an example of, let's say, simply supported beam. So what is the meaning of simply supported beam? Simply supported beam. Can you please tell me what is the meaning of simply supported? Can I write, is it correct, whatever I written, is it a simply supported beam or not? First you tell me, is it a simply supported beam or not? Or do you call this as a simply supported beam? So which is correct? Can you please tell me, students? Is this called as simply supported beam, or this is called as simply supported beam, or both of them are called as simply separated beams. Can you please tell me? Any one of you? Yes.
So right side.
This one?
Yes, sir.
Yeah, why? Why it is so? Why not this one? Correct. Whatever I said is correct. This is the simply supported beam, but this we never call it a simply supported beam because we are talking about a structure, but this is not the structural system because this is an unstable system. Listen, very simple thing. When I say structure means it should be stable. Very, very important condition is that it must be stable. We will be dealing with stable system only. Are you getting the point? Something which is unstable, we never call it as a structure. Please understand that. See, so whenever I apply force, for example, imagine that I wanted to apply some force over here. So whenever I apply some force here, some force P, what happens here? Can you please tell me what would happen? Because both are the rollers, simply they roll over. Since they disappear from one place to the another place. Okay, that's why it becomes unstable. This is the unstable system. We never call it as a structure basically. You understand that? So two rollers, okay, if they are supporting a structural member, it becomes unstable. So therefore, it is not called as a simply supported beam. Okay, so this one is called as simply supported because you apply some force on it. Now, if I apply some force, will it disturb? Will it disturb?
No,
Or
sir.
it remains stable because, yes, correct. It becomes stable because the thing is that the hinge support offers resistance to horizontal loading. So hinge has the capacity to resist the vertical forces as well as the horizontal forces. Whatever the force I applied over here, the same force is taken by hinge support and reaction is going to form over here. Are you getting the point? But the reactions are not going to develop here in the case of roller support because roller support has only the ability to give or to resist only vertical loads. Only it gives the vertical reactions, but not the horizontal reactions. You understand that? So vertical reactions only resisted by the roller. Please understand that. It is the only vertical reaction that is being taken by the roller, but not the horizontal. But this is the hinge support, but the hinge support has the ability to resist the both horizontal as well as the vertical forces. That's why it is. Now, can you please tell me what is this one then? I use some other color. So can you please tell me what is this? If I have two hinges, now tell me, is it simply supported or not? Is it stable or unstable? First to tell me. I given both the sides hinge support or pin support. Some people call hinge or some people call pin also. Nothing wrong in it. We can call it as pin support or hinge support. Both are same. Now tell me, is it stable or unstable? First question is that. Is it stable or unstable? You tell me. Is it stable or unstable? It's stable. Yes or no? Yes, it's stable because if you apply horizontal force over here, will it deform? Will it be stable there or it is going to move away? To apply some force. Because these are the pin supports or hinge support, they will be able to offer resistance to horizontal load. This is also a stable structure and it is also called it as the simply supported beam, but it is a indeterminate. Why it is indeterminate? Can you please tell me? Because we have more reactions over here. We have the two reactions at one hinge and we have two more reactions at one more hinge. How many unknown reactions are there? Totally 2 here plus 2 here. Totally how many are there? Totally how many are there? 4 unknowns are there. Yes or no? Totally 4 unknowns are there existing here. What are those? Let's say if it is A support, if it is B support. So we have HA, horizontal reaction, I call it as HA. And we have vertical reaction at A, I call it as RA. So we have vertical reaction at B, I call it as RB. We have horizontal reaction at B, I call it as RB. Totally, how many unknowns are there? Four unknown quantities are HB, RA, RB. But available equilibrium equation, we have only two equations of equilibrium that are available. What are those, ma'am? Sigma H is equal to 0. Sigma B is equal to 0. If there is only forces you consider, let's say, and we have one more thing called the sigma M is equal to 0. As a whole system, we have three equations of equilibrium. So can you find four unknowns with three equations? Is it possible? Is it possible to find four unknowns? Is it possible to find four unknowns with three equations? It's not possible. That's why it is what we call indeterminate. It is stable, but the thing is that it's indeterminate, extra. Something which is extra is present, then we call it as the indeterminate. It is also simply supported beam, but it is indeterminate by 1 degree. I'll explain this. So students, first understand what I am trying to say. Just you try to understand, keep on understanding. But once I get into the basic concepts, you can understand everything very clearly. You understand? It is also what beam it is. Now tell me. It is also a simply supported beam. I'm writing as SSB. SSB means simply supported beam. But it is indeterminate by 1 degree. How much we are not able to determine? Because four unknowns are there, but we have only three equations of equilibrium, right? So how many unknowns you are not able to determine? With three equations, you can determine three unknowns. But how many are unable to determine by you? So one you are able to determine. That's what we call 4 minus 3. That is equal to 1. It is indeterminate by 1 degree. Did you understand, students?
Yes, sir.
Okay. So what about here? Can you please tell me, any one of you, just I'm trying to say here. Don't be panicked. These are very simple. It's very, very simple. Once I explain what is the indeterminacy and all, I'll take the separate chapter. It's not visible. 1 minute. I use some other color. Let it be there is a one reaction. So roller support has only one reaction possible. That is RB. How many unknowns are there totally? Can you please tell me? Here I have HA, horizontal reaction at hinge and vertical
Three
reaction.
unknowns.
Yes, here two unknowns and here one unknown. Totally how many unknowns are there? 2 plus 1. 3 unknowns are there. How many available equilibrium equations are there? These are common.
3.
Very common. So 3 unknowns with 3 equations can you find? Yes. That's why it is what we call determinate. That's why it is what we call determinate structure. One hinge, one roller is a perfect determinate simply supported beam. That's why whenever somebody asks you to draw simply supported beam, you are supposed to write in this particular manner, right? Did you understand what I am trying to say, students? Yes or no? Yes, is it clear to everyone? If somebody
Yes,
asks
sir.
simply support beam, you have to draw. One end is the hinge support, the other one is roller support. If it is a determinate simply supported beam, okay, fine, right. So now let us talk about what is the meaning of opposite to structure. Can you please tell me what is the opposite to structure? The term we call it as. What is the meaning of opposite to structure? Just now I explained about the structure, right? These are all structures. See, okay, all these are structures basically.
Which is unstable.
That which is
Unstable.
yeah, yes. That which is unstable is what we call. What is the term we use for opposite to structure called as? Can you please guess something? Look at here, students. So listen. So whenever I apply load on this particular system, so let's say your home, in your home, you are having this kind of simply supported beam. It is a beam that is there in your room, let's say where you are staying now, in a hall or whatever it is. Now, whenever I apply a load here, it can be point load or uniformly distributed load. Can you find any deformation of your beam in your building? Is it coming to down, down, down like that? Or it
No,
remains
sir.
the same? Every day is it remain same, or every day it keep on moving here and there? It remains
Same.
same. The vertical deformation is equal to 0. So you understand that? If the deformation under the load is 0, if the deformation delta V under the load is 0, then that particular element is called as the structure. I think now it is clear to everyone. Now, where we are staying in a building, that our building itself is a structure, because we can't able to see the deformation of the beam. Can you see the deformation of slab? Is your slab is bending too much every day? Are you able to see the deformation of the slab? No, you're not able to see the deformation of the slab because it's a structural element. So to call a system as a structure, the deformation it should resist. The deformation we cannot be able to see. That's what we call structure. So all the examples are simply supported beams. It can be cantilever beam. Cantilever beam also, see, cantilever beam also, because one end is fixed, other end is free. Whenever I apply load, it is able to take. You can see balconies. Look at your corridor of your college or home, you will be finding, balconies. Is the balcony deforming too much every day like this? Or balcony remains same only? Yes?
Remain same.
Remains same. Why? It's a stable system. So cantilever beam, it can be even fixed beams. Sometimes we can have encasted beams. We call them as fixed beams. So in between the two columns, it may be fixed also. The beam may be fixed completely. It depends upon the amount of reinforcement, whatever you provide. Fixed beam, simply supported beam, cantilever beam, and we can have even continuous beams. Continuous beams, several supports are there. More than 2 supports are there for a particular beam. That's what we call continuous beam. So like the continuous beams, all those things comes under basically structures. All those are structures. Now, opposite to structure, now what is the understanding you have having now? Tell me. So, can you find deformation structure, or you're not going to find deformation of the structural element? Can you see or you cannot see deformations?
We cannot see.
You cannot see something, that kind of system. That's what I written here. The elastic system or structure or body which is offering resistance to deformation is called as the, what we call structure. Against the what? Against the external loads or forces. That is what we call the structure. Fine. Now, what is the meaning of opposite to structure? There is a term, we call it as mechanism. So very important term. We are going to talk about this mechanism in the plastic analysis very clearly. What is the meaning of mechanism? It's exactly opposite to structure. I can say, if you want to understand easily, so opposite to structure is basically called it as the, what we call mechanism. So what is the meaning of opposite? So structure is what? Resisting the deformations. But what is the meaning of mechanism?
Allows deformation.
Yes, it undergoes deformation whenever we apply the load. That's what we call mechanism. For example, I have a simply supported beam. And I have, let's say, I'm going to draw something. If I am going to provide one more hinge over here, now what is going to happen whenever I apply a load? You need not even apply a load also. Let's say, just I'm applying load. What is going to happen? Can you please tell me? What is exactly going to happen when I apply load on this? It's simply, what happens? Please tell me, students. What would happen? It simply deforms. Yes or no? Yes or no? When there is a hinge, it simply deforms, and the deformation we can see delta V is nothing but deformation. That which is simply deforms, or the deformation is visible, then this is what we call the unstable system. So the unstable system is called as the mechanism. You understand what is the meaning of this? The unstable structural system. The unstable structural system is called as mechanism. I hope it is clear to everyone. Is it clear to everyone? Suppose listen, actually the yellow line, whatever I drawn is a structure. But I introduced some hinge. By some reasons, I applied some hinge over there. Hinge means a link, whatever I apply. You look at chain, now you might have seen chain, whatever it is. Will it be stable? Because it is connected by links, it is going to automatically, due to self-weight itself, also it is going to deform down. It is not able to sustain, right? Link. So something called, a hinge is provided here. Then this particular structure itself is converted to mechanism. It's allowing the deformation. So that which is going to deform is basically called as the mechanism. Do you understand whatever I'm trying to say? The system which do not offer resistance to deformation. Okay. The system which do not offer resistance to deformation, that particular system is called as the mechanism. Being a civil engineer, do you construct the structure or a mechanism? Please tell me. Being a civil engineer, yes, we never construct the mechanism. Basically, mechanism means unstable system, which is going to fail. Okay, completely. That's what we call mechanism. We'll be dealing with structure only. But whenever there is some kind of hinges are created because of any damage and all, the structure itself is going to convert to mechanism. Whenever there is an earthquake happens, you might have seen, okay, recently some kind of earthquakes are happened, okay, in some other country. So what happens is that in the presence of earthquake, it leads to breaking of the reinforcement and the hinges are going to form. The structure itself will become a mechanism, and the mechanism is nothing but unstable. The unstable one gets collapsed, basically, right? That's what we can say. Okay, so that is what the difference, basic difference between structure and mechanism. Now, let us see what are the classification of structures. Let's look at that first. Okay, so classification of structures we look at. That is our thing. I'm going to explain clearly. So classification of structures. We'll look at this first. So try to be focused to the class. You can understand everything. And at the end of this course, you will be feeling that the structural analysis is very simple. So don't be panic. Most of the civil engineering students will be very much afraid of the structural analysis. They feel that's very difficult. But once you attend my course without missing any class, I can assure you that you feel that this subject is very interesting and very easy also. Okay, that's what you will be able to say at the end, provided that you attended all the classes. So we'll see one by one. So what are the classification of structures? So first we'll see we have some bases. There are different bases on which the classification of structures can be done. So the first one is all about based on the dimensions of members. So based on dimensions of members or elements, we can say. So based on dimensions of members or elements, so how do you classify the structure? We'll see. That means member dimensions. So for example, you have a structure. Look at your own building. You have different elements. We have beam element. We have column elements. Yes or no? So different, we can say members or elements, whatever it is. So beam is a one element or beam is a member, we can say. Column is a one element or member, we can say. So based on that dimensions of the elements or members of a structure, how can we classify the structure? Let us look at that. The first one is what we call as skeletal structure. What is the first one I call it as? Skeletal structure. So can you please tell me what is the meaning of a skeletal structure? Can anybody tell what is the meaning of skeletal structure? Can you please tell me what is the meaning of skeletal structure?
Skeletal. It only has frames.
For example,
frame structure.
Yeah. Please tell me what you are saying.
It only has frames or column and beams, slab.
Okay, good. Fine. Can you please elaborate it if you want to understand everyone, for example? It has beam, column, fine, okay. Still?
Sir, I think it is without walls.
Fine, okay, good. How to exactly define skeletal? So listen, dead bodies, if you see, so we can say skeleton. Some after a few days, it's a skeleton. Skeleton means what? You'll be finding thin members, right? Only bones you can see. In movies and all, you will be some people they'll be showing that, right? So to make others fear, so they keep skeleton, right? Something, you know. So skeletal means what? It means, listen, very thin element. That means only one dimension is predominant when compared to its other dimensions. Listen, for example, you look at this pen, let's say, for example, in this pen, I have basically two dimensions because it's a cylindrical one. I have diameter, I have the length. Now tell me, in this pen, which dimension is predominant? Is it the diameter is predominant or length is predominant? See, which is having more dimension? Is it length or diameter?
Length.
Yes.
Length.
Yes, that's what. This is what we call skeletal element. So if in a if it in a structure, basically, if the element, whatever we take it out, if it has one dimension is very predominant when compared to other dimensions. In a structure, I'm repeating the same thing. What is skeletal structure means? It is a structure in which the elements are having with one dimension is predominant when compared to other dimensions. So one dimension is very, very large when compared to its other dimensions. Such kind of structures are called as the skeletal structures, basically. Okay, if it is a pen, we have diameter is very, very small when compared to length. And if you look at any box, some kind of, very simple, you can say even rectangular box, whatever the element, in rectangle, you can find two dimensions, width and depth, but length is large, for example, to take it. Okay. So look at batsman, batsman you're using cricket, look at bat. It is having some width and thickness, and it is having length also. So what happened there when compared to width and depth, length of the bat is more. That's basically something like that. It's what we call one-dimensional element. Okay, so skeletal structure means if one dimension, I can write here that. So one dimension is predominant when compared to other dimensions. So one dimension. So one dimension is predominant So one dimension is predominant when compared to other dimensions. You can say when compared to other dimensions. If one dimension is predominant when compared to other dimensions, that is what we call basically skeletal structures. Can you please give some examples, basic structures, whatever you see in daily life? So for example, I can say roof truss. For example, if I take a roof truss, something like this. If I have a truss, something like this. What has happened over here?
Length is more than the diameter or cross section of the bar.
Yes, exactly. Every element to take it in this truss, every element to take it, this length is very large when compared to cross section. Cross section you cannot notice. You can see only length of the elements. Yes or no? That's what. This is what we call truss. So truss is basically what structure it is? Skeletal structure. Now you take some roof truss. We call it a simply truss or roof truss. You take it any frame. Let's say for example, this is the frame I am taking. This is the frame. In this also what happened? Length is very high when compared to the dimensions that are not visible to you. It can be this kind or it can be any kind of shape, whatever it is, doesn't matter. It can be curved, parabolic, or it can be even triangular. Doesn't matter, whatever it is. Like this. But what we can see, length is very, very large when compared to other dimensions. That's what we can say. If one dimension is predominant to one when compared to other dimensions, we call that as the skeletal structures. Example, trusses, frames. These are all frames, basically. This one and this one, these are the frames. Are the examples for skeletal structures. Listen, all our structures are considered as skeletal when you do analysis. Please understand that. Except slab elements. Okay, I'll explain what is a slab element. So we'll see that. We'll come to that. But other than that, every beam element, column element. These are what in a frame, in our building. This is the beam now. Horizontal element is what we call beam, but the vertical element we call it as column. In column, height is more when compared to cross section. In beam also, length is more when compared to cross section. Obviously, we idealize all elements are the skeletal elements, and we start analyzing the structure basically, right? You understand that? Fine. Now let us move on to the. Is it clear to everyone? Any questions are there, students? Is it clear to everyone?
Yes, sir.
Fine. The next one is that, what are the meaning of surface structures? Can you please tell me what is the meaning of surface structure? So when I say skeleton means one dimension is predominant when compared to the other dimension. But what is the meaning of surface? Look at your slab. In a slab, two dimensions are predominant. What are the two dimensions which are predominant? Can you please tell me?
Length and width.
Look at your top of your building room now, where you are situated, where you are sitting now. Look top. You can have slab width and length. Length is there, width is there. Very visible. They are very, in terms of meters you can find. What about thickness of the slab? It is in mm, like 100 mm, 120 mm, like that. Nothing more than that. We cannot find thickness of the slab in meters like that. Okay. So that's what. So when two dimensions are predominant when compared to thickness, that is what we call surface structures. Did you understand? Skeletal structure means one dimension is predominant. What is the one dimension? Length. If length is very, very large when compared to width and thickness, that is said to be a skeletal structure. Next one. Surface structure means if two dimensions are predominant, that's what we call surface structure. Basically, that means length and width are very large when compared to thickness. That means two dimensions are comparable here. So if two dimensions, I can say if two dimensions are predominant means dominating, nothing but. If two dimensions are predominant compared to other dimension means compared to thickness. That means length and width are actually dominant. Basically, length may be more than width, fine, but this is very, very large when compared to thickness. That is, which fellow is very small? Thickness. T means thickness. Thickness is too small, but length and width are almost same. Then that kind of two dimensions are predominant. We call it as the surface structure. What are the examples for this surface structure? Can you? But the slab, if you look at, it is having some length. Yeah. So are you able to hear me, students? Are you able to hear me, students? Anyone of you?
Yes, sir. Yes, sir.
Okay, fine. So slab example is that, and we can have even roof sheets, slabs, roof sheets, especially in steel structures. You can find railway stations and all, metro stations. You can find roof sheeting basically. Industrial buildings, you can steel buildings, especially we'll go for roof sheets. Okay, now listen. What kind of roof sheet you prefer to have? So would you like to have curved roofs or we can say plain roofs otherwise? Can anybody tell what kind of roof sheet you prefer to have? If you are given opportunity, which roof you are going to choose? Is it curved roof or flat roof?
Curved roof.
Curved or flat? Can you please tell me any one of them?
Sir, curved.
Curved. Why curved? Why not flat? You are given
Sir,
a
in curved forces distribute for the even distribution of forces, sir, in curved surface.
even distribution of
Load.
even distribution of load. In which element?
In curved surface.
In curved surface. Is it correct? Can you please come again once again? What did you say?
So transferring of load will be
Ah,
even in the curved surface, sir.
curved surface is even. Okay. Is it correct? In this thing, so for I am drawing something called a curved surface. Are you able to see? This is the curved sheet. Yes. Yes or no? Let's say I am using given thickness. This sheet, I am talking about sheet. Sheet is having definitely some thickness. It is having some thickness. It is a curved sheet. Imagine a sheet, right? So, and it is having some, its own centroid axis there now. Yes or no? It has its own centroid axis. Yes or no? Any element you take, its centroid element is there, right? Centroid is there. Now, I am taking, I hope you are able to visualize what I am trying to draw. So I can have other one is what we call flat surface. This is the flat. Now tell me which roof sheet you prefer. Being a civil engineer, which roof sheet you prefer? I use some other different color. Now tell me, I am drawing neutral axis. I am going to draw neutral axis. This is the neutral axis. I am having here like this. This is the neutral axis. So if we draw neutral axis over here, this is the neutral axis we can have. Now tell me, this is what we call flat roof. This is what we call curved roof. Now my question, did you understand? This is asked in some of the interviews and also some of the examinations also this question is asked. Which roof sheet you prefer? Is it a flat sheet or curved roof? Curved sheet. Even you might have seen at your home, nearby home, somebody have used this kind of sheets for the construction of their homes. Sheet means a steel sheet, thin elements, basically. So to call any element as a sheet, its thickness should be less than 5 mm. Then only we call it a sheet. Otherwise, we don't call it as a sheet. We can call it as a plate. Okay. Thickness should be less than 5 mm to call it as a sheet. Now tell me which roof sheet you prefer, flat or curved. Very simple. You know moment of inertia formula? Yes or no? Any one of you? Do you know or not? Moment of inertia formula. I is equal to ay square or ar square. Yes, have you heard about this?
Yes, sir.
I is equal to ar square or ay square. You might have used any terminology you can use. So r, y are what I written here, y, let's say. I is equal to a. That means moment of inertia is the second moment of an area. You might have learned in engineering mechanics. For example, if you forgot also, no problem. See, in my class, I assume that everything you've forgotten. That's what I'm assuming and I'll keep on teaching. So I can say moment of inertia means the second moment of an area. So here we have area into y, that becomes moment of an area. Into y, if you do, 2 times you're multiplying with distance, that's why it becomes a square. That's why 2 times the square of the distance, that's why it is about the second moment of an area. Second moment of an area is called as the moment of inertia. Now, y indicates what here? Here, y means distance of the fiber from the neutral axis. So, what are the distance of the fibers here from the neutral axis? Can you please guess here? So, if you observe here carefully, so this is what y is basically. So, y is large over here in the curved roofs. Look at over here. So, y is here. So, y is a large distance. As long as if it is, if the material is distributed over a long distance, what would happen to this?
Like to include.
Sir, your voice is breaking, sir.
Now, are you able to hear me properly now? Are you able
It's
to hear me?
little breaking, sir.
Okay. That may be because of some network issue. Now it is clear to you?
Yeah, sir.
Fine, fine. So y is about talking about the distribution of material from axis. So y means here, what is the y over here? So when I say y means distance of material from neutral axis. Distance of material from a reference axis, from neutral axis, let's say, I am taking here. So more the distance you're having y, what is the moment of inertia also? Please tell me, if y is more, what is the moment of inertia also? What would happen?
It
If
will
y
also increase.
Increases.
increases, exactly, very good. So that is what exactly happening in the case of curved roofs. In the curved roofs, since the material is distributed far away from the neutral axis, material is distributed far away from the neutral axis, moment of inertia increases. If moment of inertia increases, what would happen? What is the advantage of having more moment of inertia? Can you please guess something? So we have bending equation. You know bending equation? Any one of you? Please tell me. What is the bending equation? M by I is equal to F by Y. Yes or no? Is equal to E by R. So E by R we are not going to make use of. So what is the bending moment equation? Bending moment carrying capacity. Nothing but F by Y into I. Yes or no? Yes or no? Please tell me. If moment
sir.
of inertia is more, what is the moment carrying capacity is also? Please tell me. If moment of inertia is more, what about moment carrying capacity is also?
Increases. Will
Yes.
be more.
To each other. See, now tell me which, listen, whereas in this case, what is happened? The material center of gravity and neutral axis both are coincident. Have you noticed that? Yes or no?
Yes,
So
sir.
that means material is located very, very nearby. Material is not distributed far away here from the axis. It's very closer. Y will be very, very less for this. If Y is less, what is the moment carrying capacity? What if Y is less, moment of inertia is also less? If moment of inertia is less, what about moment carrying capacity is also less? So which element will carry more moment whenever you apply some load? Is it curved roof or flat roof? Please tell me.
Curved roof.
Curved roof is able to take maximum moment. You understand that? So it is
Yes,
preferred.
sir.
So curved roof is preferable when compared to flat roof because they are able to take the more moment. So more moment they can able to resist when compared to flat roof. You understand the difference between them? Is it clear to everyone? Yes, students, any one of you? Any questions? Is it clear why people are most of the sheets are prepared in this manner, but not in this manner? Reason is that this curved roofs are able to take the more moment because of their geometry. Any questions? Is it fine? Yes.
Yes, sir.
Yes, sir. Yes, sir.
These sheets we use only for trusses, basically, roof trusses. Somebody's messaged. Any questions? Okay. Now let us move on to next slide. Next slide is not.
Sir,
Yeah, tell me.
sir, can you say the difference about roller, fixed and hinge support, sir?
Yeah. Next thing is once I explain structures now, I explain about all those supports and all. Don't worry. I'll explain
Okay, sir.
very clearly. I'll explain. You will never forget in your life. In that,
Oh, okay, thanks, sir.
yeah. But I'm not going able to go to next page, next slide. 1 minute. Okay. So we have, listen, you have seen what are the different types of structures, right? So far, what are the two different type of structures you have seen so far? One is the skeletal structure. What is the meaning of skeletal structure? Only one dimension is predominant
Predominant.
compared to other. Yes. What the surface structure means? If two
Two
dimensions.
dimensions predominant.
Now we have something called as solid structure. What is the meaning of solid structure?
All dimensions are predominant.
Yes. If all the dimensions are, how many dimensions are there basically? 3 dimensions, right?
3 dimensions. Yeah.
If all dimensions are good amount, width, thickness, length, they're almost equal. That is what we call solid structure basically. If all the dimensions are considerable. So if all the dimensions are considerable means we cannot ignore any one of them. Considerable means almost same. If all the dimensions are almost same, that means we cannot neglect any one of them. Any one of them is not very, very small. Almost all the dimensions are comparable. Comparable means considerable means almost same. Then such all dimensions are comparable. That means length is approximately equal to width and width is approximately equal to thickness. We call this kind of structural as these solid structures. Can you please name some solid structures? An example? Example for solid structures. Can you please tell me? A big mission foundations. Mission foundations, especially turbines. Especially if you look at turbines, a huge turbines which are producing electricity. Where do you place those turbines? In a huge kind of foundation, where all dimensions are almost comparable. Comparable means almost same. This kind of things. We cannot ignore any one of them. So length, width, and depth or thickness, whatever it is. Depth or thickness, whatever it is. Depth or thickness. Almost they are same. Nothing. Can we ignore any one of them? All are very bulgy. Yes or no? We cannot ignore. These are the different types of structures based on the dimensions of elements, basically. Elements. This is one element actually. In a structure, this is also element, basically. Okay. Is it clear to everyone? Whatever so far I explained is about what much? This is first one. But the first criteria based on dimensions of members are elements. Now, let us move on to the second criteria. Second criteria is that is based on the dimensions of frames. So based on dimensions of frame, not elements, but whole frame. We are taking whole frame, but not the elements. Whole system we are taking. So what is going to happen over here? If I take whole frame, basically. We have plane frames. You know that? What the first one is? Plane frame. So what is the meaning of plane frame? Students, please understand, whenever I say plane, plane means 2D. Please remember this. Plane means 2D. Whenever I say plane means 2D, 2 dimensions are predominant. Do you understand what I am trying to say? When I use in structural analysis, when I use the term plane means only 2 dimensions are there, predominant, but the third dimension is not there. 2 dimension structures are called as plane frames. So for example, you look at this kind of structure. For example, if I say, so look at X and Y axis here. This is the X axis. So can you see third dimension here? Are you able to see third dimension? No. Yes or no? If I take even truss, this is what? Can you see here? Can you see the third dimension visible to you here? No.
No, sir.
Are you able to hear me, students? That means,
Yes, sir.
listen, that's what we call two-dimensional frames are called as the, so I can say 2D frames are called as the plane frames. You understand what I'm trying to say? Right? Yes. So when I say space, there is something called as space. So when I say space, when I use the term space, space means 3D. What is that? 3D. So space structure means, space frame means three-dimensional frames are called as the space frames. Can you please draw space frames for this? For example, for space frame. Can you please draw on your own what the meaning of space frame? Space frame means three dimensions are present. That means you can see all the three-dimension elements. Three elements, three directions, we can have something. That's what we call space frame. Can you please draw same thing? If I look at here, all of you. Now tell me, is it a 2D or 3D? What is this? So you can find, suppose if I draw axis, X, this is Y. What is this? Z. Can you find
3D, sir.
three directions? Yes or no? Are you able to
Yes,
see the
sir.
three directions? This is the X-ray
Oh,
element.
yes, sir.
Y direction we have element, Z direction. This is what we call 3D elements. So listen, in the GATE exam or any exam you write it, they'll give every time plane figures. Most of the time in exam, you can find only plane structures. Okay, space structures, they don't give, generally they don't give. Usually because it becomes very complicated. Okay, you understand? Even truss also. For example, you look at truss. Is it a frame or truss, students? This figure, is it a truss or frame?
Frame, sir.
Frame, exactly. Because truss means it should have only triangles and it should have only pin joints. Okay, I'll explain. You'll come to know about what is the truss and all very clearly later. So this one, this is what, when I say triangular configuration and it is going like this, and keep on going like this. This is what actually. Now tell me, is it what kind of structure it is? Likewise, we have supports. And it is going like this. Likewise, it is going.
It's a truss.
Is it a 2D or 3D? Okay, truss. Exactly. Good. Now tell me, is it a 2D or 3D? Three-dimensional. It is going now. 3 dimensions. It is spreading X. It is having some height. We can have Y element also like this. We have X. We have Y and we have Z. What is this? 3-dimensional or 2-dimensional? 3-dimensional. So 3-dimensional structures are called as the what structures, man? Space structures or space frames. 2-dimensional elements are called as what elements? Plane frame. When I say plane means 2D. When I say space means, please tell me, what is the meaning of space, man? 3-dimensional. So in the examination, the questions will be very, very clear. You have to visualize that. Is it clear to everyone what the difference between plane and space? Yes.
Yes, sir. Yes, sir.
So plane means 2-dimensional elements. Space means 3-dimensional members. Next. This is the third classification we look at now. Based on the joins. The third classification is all about based on the joins. So based on joints, whatever we are having, the structures are classified into two types, pin jointed and rigid jointed. So let me write over here. So basically your structure is divided into two. One is based on joints only, how they are joined. So we have pin jointed structures. So we have even rigid jointed structures. Pin jointed structures and rigid jointed structures. Two things are there. So pin jointed structures are how many types? Once again, Can you please tell me? Just now I told structures are how many more? Just look back. Based on dimensions of the frame, how many are there? Plane and space. Yes or no? Only two things are there. Either it can be two-dimensional or three-dimensional. Yes or no? Now here, pin jointed structure also can be two-dimensional or three-dimensional. Are you able to follow what I am trying to say, students? So first one is,
Yes, sir.
it can be plane, or it can be even. For the next one we have space. Yes or no? Yes or no? So pin jointed plane structure, or we can have in even pin jointed space structure. Two things are there. So rigid joint also, how many are there? Similarly, can you please tell me? So rigid jointed structures are also how many types? Same as it is. Listen, pin joint is divided into two. What are those? Plane structures and space structures. Similar to that, rigid joints also how many are there? Please tell me. Plane or rigid jointed can be
Yes.
space. Exactly. Now, can you please all of you draw your figures for this? Can you draw a structure for rigid jointed plane structure? Or can you draw a figure for rigid jointed space structure? Can you please all of you try? Just try. Nothing wrong in it. If you try something, you learn. So when I say plane structure and it is a pin joint, listen, ma, when I say pin jointed, it means trusses. Very good example I can say. Whenever I say pin jointed means they are what? All are what? Pin joint. If I use the term pin joint, there must be what then? Trusses. Do you understand, dear students? So when I say pin jointed means trusses. When I say rigid jointed means frames. Rigid jointed means what? Frames. If the members are connected by rigid joints, we call them as the frames. The members are connected by pin joints, we call them as the what? Trusses. Now, can you please drop, when I say plane means 2D or 3D?
2D, sir.
2D.
2D. Can you please draw a figure then? Draw a figure for this. Yes, exactly. Whatever is correct, 2D. When I say space means 2D or 3D? Space.
3D, sir.
But we're talking about what joints they connected. With what kind of joints they connected.
Pin jointed.
Now, can you draw a figure for pin jointed plane structure? This is what example I can give. Yes or no? Look at here. So all are pin connected. Joints are pin connected. Is it 2D or 3D? Can you see 3 dimensions or only 2 dimensions are visible?
Only 2D, sir.
This is what we can say pin jointed plane frame. We can say frame. Pin jointed frame means truss only. Listen, students, don't get confused. Even though in examination, if they give pin jointed frame means truss only. Okay. Now tell me, can you draw structure for space structure? Space pin jointed structure. Space pin jointed structure. Same, but it is going to extend in 3 dimensions. For example, like this. Now tell me, is it what is this? Let's say I give in this manner. The same thing is extended. Now tell me, is it what kind of thing it is? What is this? Is it a space or plane? It is space X, and we have even, let's say, we have something called the supporting element. We have X, we have Y, and we have even Z. Is it 2D or 3D? This one. This is the space structure, right? 3-dimensional. Can you draw similarly rigid jointed plane structure? So when I say rigid jointed planes, I'm talking about rigid jointed. All the joints are connected with rigid, like this. This is the rigid. These are the rigid. Now tell me, is it a 2D or 3D? This one.
2D, sir.
2D. That's why it is a pin joint. Plane means 2D. Now can you draw a figure for space structure? Rigid jointed space structure. Space means 3D. Now tell me, is it what kind of structure it is? What is this? We have 3 dimensions here. X. We have Y. And we have Z. Is what structure, madam? Space. 3 dimensions are there. Now, did you understand the difference between all these? This is based on the structure. Once again, what structures all these are? Have I shown any dimensions of the members, or everything is like a line element? You see here. Every structure you take it, do you find any thickness, width, depth, or only length is visible for every element?
A length is visible, sir.
That's why these are called as skeletal, or what it is. What structures all these are? If only one dimension is visible or predominant when compared to other dimensions, we call them as what structures? Written already here.
Skeletal, sir.
Yes. So skeletal structures are based on the joints. The skeletal structures are divided into how many? They can be pin jointed. Number one, they can be pin jointed. The second one is they can be what? Rigid jointed. And everything, it contains 2 things. One is plane and space. Plane and space. Okay. Do you understand the difference? Difference between skeletal. Listen, because why I'm talking about only skeletal structures? Because throughout our structural analysis, we use only skeletal structures. Okay, that's what it is. Every element, every structure is considered like a skeletal structure, and we start designing it. So based on the joints, the skeletal structures are divided into pin jointed structures and rigid jointed structures. I hope it is clear to everyone. Now, can you please tell me what is the difference between rigid joint and fixed support? Can anybody tell what the difference between them? What is the difference between fixed support? What is the difference between fixed support and rigid joint? Can anybody tell? Or both are same? Can you please tell me?
Sir, for fixed support, there won't be any roller support, sir. Both sides there will be only fixed.
Both,
Or I mean, both sides there will be only hinged, sir.
both sides there will be?
Hinged support, sir. There won't be any roller support, sir.
No. Forget about, no, don't introduce roller or hinge. Okay, I think you got a little confused. I'm asking about what is the fixed joint or rigid joint. Fixed joint, okay. Not support. Let's say I use the term fixed joint and rigid joint. What is the difference between fixed joint and rigid joint?
So all 3 equilibrium equation are 0.
Okay, good. What is that? We call it as
Fixed support.
okay. What happens? What will be 0 in fixed support? Listen, now let me explain here. If I draw this one, is it what support symbolically indicates what? This is the fixed support. Yes or no? This is the fixed support. Says fixed support rotation is equal to there or not there, 0. Rotation at fixed support.
0, sir.
Yes, exactly. At fixed support, sorry, what happened? At particular fixed support, rotation is equal to there or not there?
Zero, sir.
Zero. At fixed support, rotation is not there. It cannot rotate. Rotation is equal to zero. What is the meaning of rigid joint or rigid support? Rigid joint means what? Can you please tell me, anyone? What is the meaning of rigid support? Rigid joint or rigid support? Suppose, oh, it's not visible. Okay, use the same yellow color. Now, if I have this kind of structure, for example, assume that all are straight only. Now, what is this joint? It is, let's say, if I want to call this as a rigid joint, what will happen whenever I apply some moment? This is the rigid joint. Whenever I apply some moment, what is going to happen? Can you please visualize this one, all of you? So when I apply some rotation, every element undergoes the same. Every element undergoes the same amount of rotation. Every element, whatever it is. Every element has to undergo the same amount of rotation. Did you understand this, all of you? This is what we call rigid joint. At rigid joint, every member undergoes the same amount of rotation. If this is theta, this must be theta. This must be theta. This must be theta. This is the rigid joint. So I can say this is the rigid. Whatever the joint it is meeting now, this is what we call as rigid joint. At rigid joint, every member, whatever is connected, undergoes the same amount of rotation. But fixed joint means at fixed support or fixed joint, while the rotation at fixed joint or fixed support mode, it does not allow any kind of rotation. Rotation exactly theta is equal to 0 over here, but theta is same for all the members which are meeting at the rigid joint. That is what the difference between the rigid joint and fixed support. You understand the difference? Otherwise, you can take even this kind of structure also. For example, if you are given this kind of frame, so whenever you apply some load, this is the rigid joints, all the members are, whenever I apply some force, because of that force, it undergoes the same amount of rotation at both the joints and the same displacements also. This is what exactly. So the displacement would remain same delta. And rotations are same. This is the difference between, basic difference between the fixed support and rigid joint. Some of the examinations, even they ask this kind of questions also. Did you understand the difference between rigid joint and fixed support? At rigid joint, we can have, listen, rigid joints can undergo displacement. And when I apply axial load, look at here. When I apply axial load P, rigid joints undergoes displacement. Can you listen? When I apply some axial force, can you get any displacement at fixed support? Can you get displacement at fixed support?
No, sir. No, sir.
Displacement is equal to 0. Now, why I am saying all these things is, there is a reason. Why I am explaining all these things, there is a reason. Displacement is caused by the load. Even though you apply a load at a fixed support, displacement is 0, because fixed means it does not allow any kind of displacement. Displacement in X direction, displacement in Y direction, rotation about Z axis, all are 0. That then only it is called as the fixed support. Now, what is the meaning of rigid joint? If I apply some moment at a rigid joint where several members are meeting, look at here. Here, how many members are meeting? Let's say naming also, let's say A, B. How many members are meeting? Just to see this joint. You can see clearly.
4, sir.
4. When I apply moment at that joint where 4 members are meeting, then all the 4 members undergo the same amount of rotation. That is the basic property of rigid joint, which is what extensively we use in civil engineering in analysis. When I say rigid joint means its property is, if I apply some rotation, if I apply some moment at that joint, every element will undergo the same amount of rotation. That is the basic property of which joint? Rigid joint. But fixed support, it does not undergo any kind of rotation. It's completely fixed. It does not rotate at all. It does not move in X direction. It does not move in Y direction. It does not even rotate also. That's what we call fixed. Okay. So rigid joint undergoes even displacement also. Whenever you rigid fellow, you apply force. Rigid body is rigid, but when you apply some force, it is displaced. It can displace. That is the basic difference between rigid joint and fixed support. That's why bottom figure, whatever I drawn here, whenever I apply a force, this rigid joint undergoes displacement also. So rigid joint undergoes displacement. So rigid joint undergoes displacement. Please keep that in mind. Is it clear to everyone? The rigid joint undergoes displacement. Is it clear to everyone? Yes. That's why you can see displacement here. But can you find displacement at fixed support? For the displacement at fixed support, no?
No, sir.
That's why you see here. Even this frame also, what are the supports at the end bottom? What are these?
Fixed, sir.
Fixed. That's why you don't find any deformation. Top they are displacing, but not the bottom. Bottom one are fixed supports. They don't find. That's why delta is not there in bottom, but delta you can see only where. Displacement you can see where. You can see only. This is the rigid joint. This is also rigid joint. I hope it is clear to everyone, right? Yes or no?
Yes, sir.
Fine. That's what you must understand that. Now let us see what are the support reactions are. Now I enter into somebody asked the students. Even if you don't ask, I'm going the same flow. Okay, now let us see what is the meaning of support reactions. So what is mean by support reaction? When support reactions are going to happen or occur? Can you please tell me when support reactions are going to create?
When load is applied, sir.
Okay. Can you please tell me? I'm not getting the point.
When load is applied, sir. For resisting, sir. For resisting the load applied, support reaction is going to occur, sir.
Yes, correct. Whatever I said is correct. So when restraints develops, I can say in different way. When restraints develops against deformation. When restraints develops against deformation, when restraints develops against deformations at supports, then that support, and when restraints develops against deformation at support, then reactions build up at support. then reactions develop at support. Do you understand what I'm trying to say? Please read out whatever is written. When restraints develops against deformation at support, then reactions build up at that support. Listen. Suppose, listen, my hand is a support. I'm applying some force. If this particular support offers some restraints, restraint means opposition, resistance. Okay, restraints means what? Not allowing deformation. Restraints, when restraints means not allowing, or we can say resisted. When restraints develops or resistance develops or not allowing any deformations, when restraints develops against the deformations, that means deformations are not allowed, then reactions are going to develop. So, okay, why I said like that? I think don't get confused. There's a reason why I written this definition. Let's say, for example, you go with the first one. I'm going to talk about a kind of support called as, first one I talk one by one, we'll see. First one I talk about fixed support. Let's say fixed support. Now tell me, I said that whenever restraints develop, reaction is going to happen. Whenever restraints develops against what? Against the deformations, then reactions develop. Now fixed support, it develops restraints in what direction? Can you please tell me? Can you please tell me what is going to develop? This is what we call fixed support. Tell me, fixed support restraints what? Fixed support restrains displacement in X direction, displacement in Y direction, and rotation about Z direction. Therefore, how many reactions it has? Listen, how many number of restraints are there? Those many number of reactions are going to develop. Therefore, it has how many reactions? Fixed support. Now tell me, any one of you?
3, sir.
Therefore, we get reaction in vertical direction. Can I write VA? Otherwise, I write reactions as R. So I can have reaction in Y direction. I can have reaction in what direction? X direction. And we can have even, listen, this is the X axis. I can say here, this is the X axis. This is the Y axis. And this is the Z axis. Okay. So this fixed support does not allow the member to displace in X direction. It does not allow the support to displace in Y direction. It does not even allow the rotation about Z axis. Therefore, how many reactions we are going to develop then? It is going to develop 3 kind of reactions. You understand? So what are those? Because it is restraining delta X, we can have Rx. Because it is restraining in Y direction, we can have what here? Ry. Because it is not allowing rotation about Z axis, there is a moment is developed. How many reactions are developed totally? Fixed support is having how many reactions?
3, sir.
3 reactions. Listen, this is the best way of learning the things. Otherwise, you'll get confused unnecessarily. So what are the 3 reactions? Reaction in X direction, reaction in Y direction, and moment about which direction? Z, because Z direction only moment is happening. Now, can you please tell me what about the hinged support? This is all about which support? Fixed support. Now, can you please tell me about hinged support? This is what we call hinged support. Now, what does it hinged support restrains? Can you please tell me? Hinged support, it restrains what moments, what directions?
X and Y, sir.
It restrains displacement in X direction, displacement in Y direction only. But there is no rotational effect. Now tell me, what are the reactions? How many reactions we are going to have?
2, sir.
What the directions restraints are developed, that direction only we can have reaction. So we can have reaction in X direction. Yes or no? Yes. We can have reaction in Y direction. That's it. Hinge support is having how many reactions then? Hinged support is having how many reactions? Only two reactions. What
Two,
are
sir.
Rx and Ry? Now I am going to talk about the third one. The third one is, what is the third one? Let's say roller support. So when I say roller support, how the roller support will be, ma'am? I'm going to show roller support as like this. Or some people also represent in this manner also. Either
Sir,
way it is-
both hinged and pinned are same, no, sir?
Hinged or pinned. We can say even pinned also. We can say even pinned or pinned. Fine. So now tell me if you really understand, it restrains what kind of motions, what kind of displacement it only restrains.
Only Y direction, sir.
Yes, it restrains, it's clearly visible to you. It offers resistance. Resistance means restrains. It restrains displacement. Delta Y means displacement. Delta symbol is used for displacement now. I am using the symbol delta. Delta here means rotate, generally transverse displacement. It represents what? Displacements. Sorry. Delta means displacement. It restrains only delta Y. Delta Y means it restrains only displacement in Y direction. Therefore, how many reactions it has then?
One.
How many reactions it has then?
One, sir.
One reaction. That reaction is also in one direction. So listen. Either we call this one or this one as roller. Not both of them. Either this one or this one. Any one of them we can use for convention as a roller support. It has only how many reactions? It has only
One, sir.
one reaction. That is only in one direction. So can we stop here? It is 2050. If it is the elastic spring, can you please tell me how it will be? If it is the elastic spring, for example, in this manner. If it is the elastic spring, how many reactions we can have here? Can you please tell me? I'm talking about elastic spring, not torsional spring. It's only elastic spring.
Only one, no, sir.
What is that only one?
Del Y, sir.
Yes. It only offers, whenever I apply a load, it offers only displacement in Y direction. Therefore, it has only how many reactions? Only
One.
to take vertical reaction. That's it. You understand what the difference between different types of supports? Yes, sir.
Yes, sir.
Suppose if I give guided roller like this kind of element. It's a guided roller. Now tell me how many displacement it offers. It restrains how many displacements?
Del Y, sir.
Now, it's what we call horizontal guided roller. It is what we call horizontal guided roller. How many reactions it is going to develop? It restrains what? Restrains what?
Rotation, no, sir.
Yes, exactly. It restrains Y direction. Now, if you apply load, can it take or not? Yes. Restrains displacement in Y direction. Restrains rotation about Z direction. What about when I apply horizontal load? Rollers are there now, parallel to horizontal force. If I apply horizontal load, it is going to move over the rollers. Yes or no? Yes or no?
Yes, sir. Yes, sir.
It has how many restraints then? How many reactions then? It has two reactions.
Two, sir.
What are the two reactions? Vertical reaction. And what is the next one? Moment reaction. Do you understand what I am trying to say? Yes or no? Is it clear to everyone?
Yes, sir.
Last one I am going to talk about. The last one. Now tell me about, this is what we call a vertical guided roller. It restrains how many directions? Can you please tell me? Restrains what? Resistance. It resists displacement in X or Y.
Why, sir?
Yes, excellent. It's very clearly visible. When I apply horizontal, it is going to move because rollers are there. It also gives restraint to rotation about Z axis. Yes or no? Therefore, it has how many reactions? Vertical reaction as well as what is this? Because